everyone, welcome back to the day 2 of TryHackMe's Advent of Cyber 2024. So the day 2 has officially begun and I've already solved, as you can see from this screen. The thing is, I had recorded earlier, but due to some file corruption, the video is corrupted and hence I'm re-recording this again. Okay, but I'm not going to go through all the contents like how I did in the earlier record, but I'll go into the very key points and the important stuff of this day two's challenge. So, day two is all about log analysis and something related to false positive and true positive during SOC analysis. So, let's dive into the video and understand about the story and then continue. The story. It's the most wonderful time of the year again, and it's also the most stressful day for the Werewolf Security Operations Center SOC team. Despite the overwhelming alerts generated by the new and noisy rules deployed, Werewolf SOC analysts have been processing them non-stop to ensure the safety of the town. However, the SOC analysts are now burning out all of the workload needed before Christmas. Numerous open cases are still pending, and similar alerts are still firing repeatedly, making them think of the possibility of false positive out of all this mess. Now, help the awesome Bevel SOC team analyze the alert to determine whether the rumor is true. The mayor is instigating chaos within the town. True positive or false positive? In a SOC, events from different devices are sent to the SEM, which is the single source of truth where all the information and events are aggregated. Certain rules, detection and engineering rules, are defined to identify the malicious or suspicious activity from these events. If an event or a set of events fulfill the condition of a rule, it triggers an alert. A SOC analyst then analyzes the alert to identify if the alert is true positive or false positive. If an alert is considered as true positive, if it contains actual malicious activities. On the flip side, if the alert triggers because of an activity that is not actually malicious, it is considered as a false positive. This might seem a very simple in theory, but practically separating true positives from false positives can be a tedious job. It can also sometimes be very confusing to differentiate between an attacker and a system administrator. So it's about describing the false positive and the true positive, which you usually get while you're analyzing logs. That too, if you're working in a blue team environment or if you're a part of a SOC team, you would know how much pain it is to look at the huge logs which is generated by the network or the servers or the event logs from a system or the active directory which is set up in the organization. All those logs, I know there are automated processes and rules which are there, but sometimes when they are flagged or when they're triggered, they're telling that this might be an incident that takes up a lot of work and it takes a lot of energy to identify if it is a true positive or a false positive in that environment. So even though the rules are written, you might not know exactly what the incident might have happened, which might have triggered this rule to be detected, right? So yeah, that's a huge task for a person who's working in the SOC team. This looks bad. Oh, how sophisticated. Must be an APT. Oh, it is just a system administrator. I mean, this scenario, anyone working in the SOC, that could be their daily routine. Making a decision. While it is confusing to differentiate between true positive and false positive, it is very crucial to get it right. If a true positive is falsely classified as a false positive, it can lead to a significant impact from a missed cyber attack. If a false positive is falsely classified as true positive, a precious time will be spent focusing on false positive, which might lead to less focus on the actual attack. So, how exactly do we ensure that we perform this crucial job effectively? We can use the below pointers to guide us. So, using stock power. Since I've already read this particular paragraph, I'm just going to tell you in summary is that if you're a SOC administrator or a part of a SOC team, you always have this power to go and question the user or the system owner who has generated the particular log. For example, you might have got a triggered log telling that password is changed or multiple login failures have occurred during the login of the system. So you always get the log from the user or from that SIM, and then you can go and question, or you can ask for an email or ask for the person's approval saying that yes, it was they themselves trying to log in into the system or was trying to do something, and that log has been generated. So that power always the SOC team administrators or the members of the SOC team always have it. So that's what they've been describing in this particular paragraph. So let's read to the context, which is a good one. While it might seem like using SOC superpower makes it super easy, it is not always the case. There are cases which can act as a kryptonic to the SOC superpower. If an organization doesn't have a change request process in place, so in case if you're changing some application or installing some application into the system, you might have a change request approval being sent from the administrator. So if that is not implemented in the organization, how will you find out, right? That's one thing. The performed activity was outside the scope of the change request or was different from that was which was approved. So you might have asked for permission to use a pen drive to install or copy paste an exe into the system, but you might be using that. That could be your change request, but you might be even installing that application which you copy to your system. So that's a different thing, which is outside the scope of the change request which you asked for the SOC team, right? So that's another alert message which is going to be generated. So it's another negative factor of a SOC team which they need to go through that log. The activity triggered an alert, such as copying files to a certain location, uploading a file to some website, or a failed login to a system. An insider threat performed an activity they are not authorized to perform, whether intentionally or unintentionally. Sometimes users by mistake might have run some exe files which might have caused for this alert to pop up. So yeah. A user performed a malicious activity through social engineering from a threat actor. Yes, that might happen. Some threat actor might have made the user intentionally or unintentionally fall into the trap of running some malicious software or application which was designed to compromise their network or system. In such scenario, it is very important for the SOC analyst to understand the context of the activity and make a judgment call based on their analysis skills and security knowledge. While doing so, the analyst can look at the past behavior of the user or the prevalences of a certain event or artifact throughout the organization or certain department. For example, if a certain user performs a network team is using Wireshark, there's a chance that the other users from the same team also use Wireshark. However, Wireshark seen on the machine belonging to someone from the HR or the finance should rightfully raise some eyebrows. Yes. So if you set up an Active Directory, you might have those organizational units which are built in. So if you're seeing some malicious activity which is or some unintended activities which is happening from the sales department or from the HR department or the finance department, which is not so techy. I mean, techy in terms of they're not related to something like scanning the network or installing applications or anything like that. So it is a concern which the SOC team is always going to have, right? So that's what they're going. That's what they're describing here. So be building a context. Correlation. While building the context, the analyst must correlate different events to make a story or a timeline. Correlation entitles using the past and the future events to recent timeline of events. When performing correlation, it is important to note down the certain important artifacts that can be used to connect the dots. These important artifacts can include IP address, machine names, usernames, hashes, file paths, etc. So basically, whenever you're performing a SOC analysis report, you need to have a timeline of what could have happened in the past, what is exactly happening, and what might that result into. So you need to have a timeline. You need to have your own assumption or a hypothesis of this is what might have happened in the past, which has given us to this date. This is the incident which it has been logged, and this might be the outcome of this particular event which has happened. So for that hypothesis which you create, you need to find a right amount of evidences, proofs, logs, and then even you need to have that approval from the system administrators saying that yes, this hypothesis seems right with this proofs and logs which are being presented. Or you need to have that evidence for your thought process. So first thing that you need to do is to build a hypothesis, collect the logs required for the hypothesis, and then make a right document related to the hypothesis surrounding to it, saying that yes, this is what has happened, this is what is exactly happening, and this is what might be the outcome of it. So yeah, what is true positive or a false positive? Similar to every SOC, an analyst in the Werewolf SOC also needs to differentiate the true positives from the false positive. This becomes especially difficult for them near Christmas when the analyst face alert fatigue. The high chances of misclassification of true positive into false positive and vice versa are present in such times. The analysts therefore appreciate any help that they could get from us in this critical, crucial time. To make matters worse, the office of the mayor has sent the analysts an alert informing them of multiple encoded PowerShell commands run on the system. Perhaps we can help with that. To help the analyst, we must start the Elastic SEM in the attached VM by clicking the Start Machine button below. This instance takes up 5 minutes to initialize and for the Elastic login page to appear. Okay, so Elastic is a SEM which is I don't know the full form of SEM. Let's Google that. SEIM. Basically, it's a system where it has a collection of logs present in it, management logs, event logs, and all those things. So, what is SEM? SEM stands for Security Information and Event Management. Yeah, it's a solution that collects and analyzes data from various sources to detect and respond to security threats. So, yeah. So basically, it is a the analyzing platform or a tool for it. Okay, so you have started a machine. It says it's going to take some time. 30 more seconds, 20 more seconds. Okay, so once the machine is up and running, we can connect to the Elastic SEM by visiting to the URL in your browser using the following credentials. So yes, I will not be reading through this. In fact, it was fun reading in my earlier recording video which I did, but unfortunately, that's corrupted. Sad. I'm sad for that. So we will directly go through the challenges. So let's come till here. Let's just browse through the contents. Let's just work around with the field, and we'll reach to this position. And then let's go to Christmas in danger. Okay, so yeah, waiting for the IP address to reveal. Open that in new tab. It says bad gateway, which means it's taking a little more time for it to be loaded properly. Okay. Okay, so after waiting for some time, the Elastic server is up and running. It says your browser does not meet security requirements for Kabina. I don't think so. That's related to the challenge. So, yeah, let's log in. So, the default credentials, which is given from here, let's just use the same thing. Elastic and Elastic login. That's loading. Okay, we'll close this. So you can go through this. You can have your own fun analyzing and reading through this. But let's stick to the challenge and go to the discover page. Okay, so In this discover page, this is where all the event logs are going to be saved, or it's going to be logged in, and then you can see what and all has happened. So, for example, if you come here in the top, it says last 15 minutes. If you click on it and then go to absolute section, you can specify you want to look at the event log from when to when, so which is a very important feature in any of the logging system, because you don't need all the data, but you just need the specific data in which the you hypothetically think that okay, this event might have happened in it, right? So yeah, so let's select November and let's take a very long keyframe, so this from 29th to now, to the present date. So let's then click on update. That gives us a lot of events that has happened during this course of time. Now, this is a lot of messy way to look into this log message. I mean, no one is going to be really curious or interested in reading in this format. That's why we have filters in here. So these filters are going to be helping us into formatting the web page into looking it into a better and nicer look, which is what they have given us here. They have specified from first, we have selected from 29, that's fine. Let's just go through the filters which they are applying. So one is host.hostname. Let's add that one here, which is host name. So let's add, or is that anyone called as host? Okay, this says host.hostname. So this is the one. Okay. So let's add this one. So which is going to filter for the timeline. One is going to be the time from when the incident has happened to the host name. So which system has tried to access or what has been happening from which system. So the host name is going to be defined here. Then they have said for the username, yeah, so we might also get a list of usernames who have tried for accessing the system or try to do something in the background. So let's go to the down window here and select for username, user.name. Let's add that filter. So it's going to say which user was trying to do what in the system that we're seeing here. It's all the list of users. It says service admin. So service admin was the account which was used for performing whatever task that was performed. Then we have event category. Okay, so it is going to specify what has happened, what category. Is it a sale? Is it a success? What did I add? Event category. Yeah. Was it a success? Was it a failure? Was it just a notification or anything like that? So all of those categories are going to come in here. And then it says process command line. So what was exactly happening? We need the command line, the back end of the whatever event what was going on, right? So for that we have, I just forgot, what is it? Process.command line. Okay. Which is here. That. So as you can see here, it says the backend logic or backend commands which were running. So we can see it here. And then comes event outcome. What was the outcome of that? Right? Event outcome. Let's add that also. So it says success here. So there could also be failure attempts. So yes, this is a failure attempts that we can see in our screen. Now, if you look at this, okay, where it looks like a lot of failure attempts had happened. If I scroll down, I see a lot of failure attempts, which says it's trying to authenticate from this particular service admin credentials from so many days with so much of usernames or the host names which was trying to brute force or something like that. So that's what is happening here. And then we see a sudden success which is happening, which means they were successful in the brute force. And we see a bit of other failure messages, which could just be the part of the brute force where before they press Control C or before the brute force actually stops, that message is here. And then whatever we see is all the success. So some script is running after the brute force was successful. That's what is storyline of this challenge. So let's. I don't know if I should go through it or not. Yeah, let's talk about these filters which we can add here, right? So okay, now imagine you want to just look at the process of authentication. What was happening during the authentication process? So you can click on this positive sign, which is going to add a filter in the top corner. And once this loads up, you will be able to see everything only related to the authentication filter. So what was happening during the authentication time? That's what we're able to see here. So we see a lot of failure and success authentication happening here. So from the username service admin, we are just filtering for everything that has happened during the authentication process. And this is the failure message. This is the success ones here, and then the rest of them are success. Not only that, I can even click on the negative sign, which is going to say, tell me other than whatever was the authentication process. So other than authentication, we see the process happening, the backend code or the commands which was used for running it. That's what is the another filter that we're able to see here, which was not evident from the authentication one. If I don't want any of these filters, I can click on this X button, which is going to give us the default view on how exactly it happened during that timeline. That's what they're describing. So yeah, and they are telling us to select. Yeah, there's one more thing. So we are adding one more IP address, I guess. So IP, source IP. So from which IP address was these connections or all those happening? We see here from this process. Let's go to the failure. We see that one IP address is trying to brute force for all these things. So all the failure messages are these from these IP address. But once it's successful, maybe the attacker might have changed their host and then started to access with this account. Okay, so we are able to see that the success messages basically. So we can even look at from what user was trying to attack and all those things. So they've added the filters of authentication. That's what they're describing it here. Okay, let's click on this negative sign to see what is going to happen here. Are there any other IP addresses than the one which we're able to see in the screen? So it says yes. So these brute forcing was done from a different IP address. That's what I was saying. So it was trying to be brute force from a different location. Once a success, it was changed to a different IP address. Okay, that's a nice thing. So we add in all these process. We can specify what exactly we want to look into and all those things. I mean, you can play around with this tool. It's completely left to you. Let's directly go to the part of the storyline. The alarms have gone off, and MSKD has been called to help take this incident further. The analysts have briefed MSKD about the incident. MSKD observed that nobody had actually looked at what PowerShell command contained. Since the command was encoded, it needs to be decoded. MSKD changed the filters with event category process to take a deeper look at the PowerShell commands. Let's also perform that. So let me clear all the other filters and add the authentication. Okay, let it come up. So let's add in the process filter, which is going to specify everything that is happening just through the process field. That's what MSKD has done. So event.category process. We see a lot of processes or the commands which are running, right? So that's what they're saying there. We can see that the PowerShell command in the process.command line. So this window here, this is the code which was running. This is the base 64 character which was used. I can say that because of this person. I mean, equal to sign in the ending of it. MSKD knows that the encoded PowerShell commands are generally base 64 encoded and can be decoded using tools such as CyberChef. Let's open that in new tab. Since the command might contain some sensitive information and therefore must not be submitted on public portal, MSKD spins up her own instance of CyberChef hosted locally. MSKD started by pasting the encoded part of the command into the input panel of the CyberChef. Let's do that. So let's copy this part of the encoded scheme into, let's copy that and open up our CyberChef, paste that in, and then let's say from base 64, pasted it there, and it's also had a filter which says decode. No, not decode. Then there's another filter which you can add, which is decode text. Yeah, I was right. So decode text. Okay, so which is going to give us a very nice format of what exactly the command was there. Now, since this is a PowerShell payload which was seen, we need to change our settings to this one, UTF-8 IDL 100 200. It is basically a formatting code, and we see that we have a command in here which says install Windows Update accept all auto reboot, which looks like a safe command. I mean, it's trying to update all the commands and it's rebooting the system. What exactly is happening? Let's go through the storyline. They have decoded it. Yes. The result provided a single line of relief to M. Skiddy, who had feared that Christmas had been ruined. Someone had come in to help M. Skiddy and the team secured their defense. But who? Villain or hero? M. Skiddy further analyzed the secret hero and came back to a state startling revelation. Revelation. The credentials for the script in the machine that ran the Windows update was outdated. Someone brute forced the system and fixed the credentials after successfully logging in. This was evident from the fact that each executed PowerShell command was processed by a successful login from the same source IP, causing failed logins over the past few days. And what's even more startling, it was Glitch who accessed the AMD one and fixed the credentials after MKD confirmed who owned the IP address. Okay, so we see that. This meant that the people of the Wavell had misunderstood Glitch, who was just trying to help the shore off the defenses. But if Glitch was the one helping the defense, who was trying to sabotage it? Was the mayor who informed the SOC about the suspicious PowerShell commands? Just like alerts aren't always what seems in the SOC, so was the case here at Werewolves with the people. As hard as it was differentiate between true positive and false positive, so was the case the mayor and the glitch. However, MSKD can perhaps use the evidence based deduction skills learned in the SOC team to make the difference easier for people of the Webel. Okay, so yeah, so answer the questions below. I have already answered it. So let's go through the process of identifying the answers in it. What is the name of the account causing all the failed login attempts? Right, because it's important. Let's come here. Let's add in the process. Let's clear all the other filters. And they have said who are all the people who are failing it. What is the account name? So we have removed everything what was not a success because we need a failure message, and we see that from the failure message that was where host 10 9 1 all those things. But what was the question here? What is the name of the account? So who was that account which was being trying to being accessed? Was the server admin. Okay, so a server admin was trying to be accessed. How many failed login attempts were observed? Now for the right amount, actually I need to set the time, which is from the beginning of the day of 29th to the absolute value of December to the end of the day, and then update it. And see, we see a list of hits that we saw. That's the number of logs which was generated against, that was observed during this event process. What is the IP address of glitch? We can see the IP address of glitch by seeing all the failure messages, and we see it's 10.0.11. But that was after they got in the password. Now, the ones which it says still a failure, but one which was trying to being accessed was this one, 10.0.255.1. So that's what is given here. When did the glitch successfully log in to the one? Yeah, we can see it from the, let's clear the message or the filter, and then let's wait for it to load up. We see that we get a single success, right? So that was the time when the glitch got the access to the system. We see a success message, and this is the answer of it. This is the time when they successfully got password to it. What is the decoded command executed by glitch to fix the system of Weevil? And we see it from here. This is the command which was used. That's nice. And then that's it. If you enjoyed this task, feel free to check it out. Okay, so I know again this was because I'm re-recording this video. This might have not been so much of fun, but I just tried my best to give out my storyline for this particular challenge. So if you did like that, if you hit on that like button and comment down below that yes, you did like it, it will be huge encouragement for me, because I had a very tiring day. On top of that, recording it for twice, and then I have to sit and edit the video now. So hitting that like button or commenting down that you do encourage me, it's going to be a big appreciation for me and encouragement. So yes, please do that. And if you're new to this channel, you can hit on that subscribe button to stay tuned and updated with all the new videos that is going to be coming up soon. Not just about advent of cyber, but other courses and everything related to cybersecurity. So if you did enjoy this video, hit on that like button, hit on that subscribe button. That's it. That's it for this video. I am tired. Bye bye. That's it. Bye bye.